Just think about the one thing that limits pretty much every piece of tech you own. It's the battery, right? It decides how big your phone is, how far your car can drive, and how often you're stuck looking for an outlet. But what if that limit didn't just get a little better? What if it just disappeared? Well, we're on the cusp of a breakthrough that could do exactly that.
So, just how big of a deal are we talking about here? Let's start by imagining a world where battery anxiety is a thing of the past.
Yeah, a world where the power source for all our most important gadgets isn't the weak link anymore, but actually the thing that unleashes their true potential.
So, what does that world actually look like? It looks like this number: 621 miles. According to pioneers like Toyota, that's how far an electric car could go on one single charge. I mean, that's like driving from New York City all the way to Detroit without even thinking about stopping.
Okay, and get this, when you finally do have to pull over, this is what it looks like. 10 minutes. That's it. That's how long it might take to completely juice up that 621-mile battery. And no, this isn't science fiction. This is the real promise of solid-state technology.
But to really get why this is such a massive, massive leap forward, we have to look under the hood of almost every single device we own today, because there's a hidden weakness in there. Right, so inside pretty much every battery you've ever used is this stuff, a liquid electrolyte. You can kind of think of it like a chemical soup that lets energy slosh back and forth. Now, this is the tech that's powered our world for decades, but, and this is the big but, that liquid is also the root of all its biggest problems.
And what's really fascinating here is that pretty much every complaint you've ever had about a battery, it all comes back to this one liquid component. It's flammable, right? That's a huge safety risk. It physically limits how much energy you can cram into a small space, which is exactly why your phone is dead by dinner time. And it just breaks down over time, which is why your old laptop battery can't hold a charge to save its life.
So, if the liquid is the problem, well, the solution is actually pretty simple and elegant. Just get rid of it.
And that's the core idea here. You swap out that volatile liquid for a super thin, stable, solid material. And here's the magic part. By making that one single change, you solve a whole bunch of problems all at once. Suddenly, the battery is non-flammable, so it's way safer. It becomes way more energy dense, so you can pack more power into a smaller space. And the research shows it could last anywhere from 2 to, get this, 5 times longer. So how does it actually work? Well, the basic principle is the same, but it's just so much more efficient. When you charge it, lithium ions still travel from one side to the other, but instead of swimming through that chemical swamp, they're zipping through a perfectly engineered solid structure. So yeah, think of it less like a swamp and more like an ion superhighway. It's incredibly fast, direct, and way more efficient. But this is where the story gets really juicy. See, scientists haven't just found one material for this superhighway. Oh no, they've actually found a few. And now, it's a full-on race to see which one is going to win. Okay, so there are 3 main contenders in this race, and each one has its own pros and cons. First up, you've got oxides. Now, as you can see, these are super stable and safe, but they're also kind of brittle, like ceramic, which can make it hard to keep a good connection. Then you've got the sulfides. These are the speed demons, the fastest superhighway for ions, but they're really sensitive to plain old air and moisture. And finally, there are polymers. These are flexible and pretty easy to make, but their performance isn't quite there yet, so for now, they're probably best for smaller, low-power gadgets. The real trick, the billion-dollar question, is how to get the best of one without the worst of another. And that brings us to the big reality check. If this tech is so amazing, why isn't it in your phone right now? Well, because, as it turns out, inventing something in a lab is one thing, but making millions and millions of them is a whole different ballgame. Yeah, the road from the lab to your pocket has some pretty serious hurdles. First off, the cost. Right now, the materials and the manufacturing process are just plain expensive. Second, durability. You have to make sure those solid layers stay in perfect contact, like microscopic level contact over thousands and thousands of charges. And last but not least, there's pressure. Making these things requires incredibly high pressure to get the layers dense enough, and trying to do that on a massive gigafactory scale, that's a huge engineering puzzle to solve. But, and this is important, don't get me wrong, companies are pouring billions of dollars into solving these exact problems. Why? Because they know the payoff isn't just a slightly better battery, it's a completely different future. And just look at the money pouring in. It's staggering. Analysts are projecting that the market for solid-state batteries, which is basically nothing today, could explode past $10 billion by 2036. This is not some small-time lab experiment anymore. This is being seen as the next major wave in energy tech. And you know what? We're going to start seeing this stuff sooner than you might think. By the end of this decade, some projections say that up to 30% of our consumer electronics could be running on solid state. Just think about that. Thinner phones, laptops that actually last for days, and wearables that can do things we haven't even thought of yet. The impact is just going to be everywhere. For electric cars, it's the end of range anxiety, period. For our phones and laptops, it's freedom from the charging cable. For our planet's power grid, it means we can store solar and wind energy way more efficiently. And for cool stuff like robotics and AI, it's giving them the powerful, compact energy source they've been desperately waiting for. So when you boil it all down, it comes to this. This isn't just a small step up. It's a foundational shift in technology, one of those really rare breakthroughs that has the power to completely redefine how we live, how we work, and how we get around. And that leaves us with one final and really exciting question. We are right on the verge of taking away one of the biggest technological roadblocks of the last 100 years. So when the battery is no longer the thing holding us back, the only real limit is our own imagination. What are we going to build next?